Yeah, good morning, dear students. So this is Dr. Vijaya Babu. So we are deeply discussing about the concepts of current electricity. So in the last session, I think I have discussed about the KVL, Kirchoff's voltage law. So we have done simple methods to apply KVL. So we'll try to consider some more problems, deep problems to understand the concepts of KVL. Okay, so let us consider the problems regarding this KVL. Yeah, so now this is a simple problem what I have took about this KVL, that is a battery is connected. I think two batteries I think I have connected in a loop, right? So in a single loop, and four different resistors R1, R2, R3, R4. So all of them are connected in series. So this 4 volts battery and R1, R2, R3, R4 and this minus 4 volts battery. So everything they have connected in series and they have made a loop, and the current what is flowing through it, what is mentioned, it is the value of I. So for this, just the question is actually, so apply KVL. That's it. So how will you apply the KVL to this loop? Okay. So to understand this, actually, the point what has mentioned is the current flowing through this, through the current entering the negative terminal of the 4 volts battery. Okay. So that is I current. So if you deeply observe the insights about it, the current coming out of the battery also same thing, na? And the current coming out of the battery also same thing. The current coming out of the battery also same thing. Here also. Okay, here also the same current. 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 Okay, now, so the best approach, what I will try to understand using the after keeping the notation for the current flowing in this loop. So what I try to consider simply, so I am a person, so for me I'll try to use the green color to apply the KVL. That means I need to walk along this loop. Okay, I need to walk along this. I start at this point. Okay, then I'll try to walk like this. I'll try to walk like this, and I'll try to complete the loop. Okay, and the algebraic sum of voltages is exactly equal to 0. So what the KVL is saying, in a loop is equal to 0. Now I'm walking like this. First of all, I am touching what? I am touching the negative terminal of the battery. Okay, I am touching the negative terminal of the battery means minus V I need to consider. Okay, negative terminal of the battery I am considering. Then I'm walking like this, walking like this, walking like this, walking like this. So now you need to understand that one more important thing is the current is coming with you or not. Okay, if current is coming with you, that means current with you, take it as positive terminal. Current opposite, take it as negative terminal. That means here at the R1, the current is coming, the current I is coming with me, right? So as the current I is coming with me, the drop across this R1, I need to consider it as plus IR1. This is how I have written using Ohm's law. Ohm's law, you know that V is equal to IR. Everybody knows that V is equal to IR. Easily you can apply Ohm's law everywhere if you know the resistor value and the current flowing through it to calculate the voltage drop. So V equal to IR1 you can easily apply. But the point here is very important is what is the sign convention you have to consider to apply this KVL. This is most important and most crucial thing what you need to understand in applying the concept of KVL. Okay, so that means if the current is coming with you, na, so immediately if the current is coming with you, if at all it is entering at R1, you take it as positive terminal, positive sign, that is plus IR1. Now you're going ahead. I'm showing myself with the green color. Now I am at R2. I stand here and I'll observe what about the current. Current I is coming with me or opposite with me through the resistor R2. Here also the current coming along with me, that is, I'll try to consider it as IR2. Okay, then once again, I'll try to take the green color. I'll try to go ahead. Now I am at R3. So when I am at R3, try to understand. Observe about the current. Current is with me. So try to consider the same logic I will try to apply in the mesh and nodal analysis also. Okay, if current is coming with me, here I'll try to take it as a branch current or a loop current. Okay, because it is single loop, na? There multiple loops will be there in applying the nodal analysis and the mesh analysis. There I'll try to consider the loop current. Here also the loop current. So the loop current is coming opposite to me. I'll try to consider it as the negative terminal. So whenever I'm going ahead, this green color one. Okay, now you're standing before R4 and observe about the current. Current is coming with you. So once again, if the current is coming with you, take it as positive. Then the drop value is magnitude is IR4. Then you are moving ahead. Now you are touching the negative terminal of the 4 volts battery. So that is how you are writing here as -4. And then you have a long conductor. Will there be the voltage drop in the long conductor? No, because it's an equipotential body. The difference will be 0. There will be no drop. So which is equal to, now you are coming back to the same point once again. Finally, you come back to this point once again. So this is exactly equal to 0. So this what KVL will say us. Now from this analysis, simply I can write I into R1 plus R2. I'll try to take this I as common. R4 is exactly equal to V plus 4. So this is how you need to apply the concept of KVL for the problem what I have took. Okay, so hope it's very clear, right? So just I have applied it. It is nothing to found anything because more variables are unknowns are there. That is V is unknown, R1, R2, R3, R4 are unknown, and the current I is also unknown. So nothing to calculate about them. Just you need to apply what the question is. The question is just to apply KVL. So hence I have applied the KVL for the simple problem. I'll try to go ahead for the next problem. What I have to. This is a simple problem. What I have to. And here the question is calculate voltage across 3 ohm resistor using KVL. So this is the question. Okay. So now, so before understanding this, first of all, I'll try to apply KVL by considering this, what you call it as the current in this loop. Let us assume the current coming out of the battery is I. I don't know the value of I. The same current will enter the 2 ohm resistor. The same current will enter the 3 ohm resistor. The same current will leave the 3 ohm resistor, and the same 3 ohm current will enter the negative terminal of the 10 volts battery and comes out. It is a single loop, right? So same current I runs throughout this loop. Now to calculate the value of Vx, first of all I'll try to calculate the value of current flowing through this loop. So how will you calculate the current? Now once again the same principle, you start walking in the loop. So you start walking in the loop means you start here. Okay, you stand at the 2 ohms resistor. You stand at the 2 ohm resistor and observe about the current I. Is current I coming with you or not? Yes, exactly. Current I is coming with you. Then take it as a positive drop. Positive drop across 2 ohms means apply Ohm's law. Resistance value into current flowing through it. Okay, similarly, next you go ahead in walking little more and you are reaching the 3 ohm resistor. So exactly at the 3 ohm resistor, what you are doing? So exactly at the 3 ohm resistor, the current, observe the current, how it is coming. Current is coming with you. Very simple logic, right? So you can consider plus. So this is also plus and this is also plus 3i. Okay, then once again you start walking. You don't stop the walking now. You should walk throughout this loop. That is most important in applying the concept of KVL. So you're standing at the negative terminal of the battery. That means you're touching first the negative terminal of the battery. That is why you have to take minus 10. If you cleanly observe all these terms, what I am adding or subtracting, they are voltages. If it is a battery, it is a voltage. If it is a resistor, it is a voltage drop. That means IR drop. Okay, Ohm's law. So minus 10. Now you don't stop walking, right? So you should walk continuously throughout the loop. And finally, you come back to this point once again. Reach the original point. That means you have completed the loop. That means that is exactly equal to 0. So from this logic, simply 5i is equal to 10. So I is equal to 10 divided by 5, which is equal to how much? 2 amperes. So using KVL, what I have done? I have applied KVL in this loop and I calculated the current 2 amperes. Okay, now to calculate the value of Vx, okay, so value of Vx is very simple. Vx is exactly equal to, okay, so that means current is touching the positive terminal of Vx na, so no issues grantedly. This is resistance into the current. This is very important observation what you have to consider. Okay, this can be 3i or minus 3i. You should have a clarity. There is ambiguity between 3i and minus 3i. Here the current I is entering the positive terminal of Vx. That is why I'm taking it as Vx equal to plus 3 into I. That means the value of Vx is exactly equal to 3 into 2 amperes, which is equal to 6 volts. 6 volts. Okay, so this is one approach how I have calculated the value of Vx. So instead of using this method, without using this KVL, is it possible to calculate the value of Vx directly? Calculate the value of Vx directly? Yes. Grantedly, you can apply voltage division principle. Okay, that means voltage division principle. So what the voltage division principle is saying? So voltage division principle Vx is exactly equal to same voltage, that is same resistor value 3 divided by total resistance 2 plus 3 multiplied with total voltage supplied 10. Okay, that is equal to 3 by 5 into 10. So 2 times, how much is the voltage? It is simply 6 volts. Okay, so instead of the different approaches where you can plan in applying the, what you call it as the different methods in the electrical circuit analysis, okay, so that you can calculate the value of unknown parameters using different approaches. Okay, so we'll try to go ahead in solving the next problem. So this is using the KVL. Once again, you need to calculate the value of V1 and I1 using KVL. Okay, so now, so to apply KVL, once again, what I said, I should walk around this loop, right? So yes. So once again, I'll try to mark this value of current. So whatever the current here I have shown in the problem, the same current will runs throughout the loop, throughout the loop, throughout the loop. So same current I runs throughout the loop. Next, you start walking. I show with the green color. So you start from here. Okay, you walk something like this. So first you are touching the negative terminal of the 26 volts battery. This is plus and minus na. So that means touching the negative terminal of the battery, that means minus 26. Then you start continue walking. Okay, so you'll try to consider the voltage drop. Here stand at 2.2 ohm resistor and observe the direction of the current. Current is coming with you or coming opposite to you? Current is exactly coming with you. If the current is coming with you, immediately take it as what? Plus 2.2 I. This is a drop across 2.2 ohm resistor. Then you should not stop walking now. You should walk. Go ahead. You are touching the positive terminal of the 9 volts battery. That means take it as plus 9. In confusion, sometimes you will be able to write this 9i. It is not 9i. Okay, it is a voltage na. So voltage, it is a battery, directly battery have a potential difference of 9 volts. So that is how you need to consider only 9 volts. You should not apply Ohm's law for this. Okay, Ohm's law is only for the voltage drop across the resistor. So that is the clarity you must compulsory maintain. Now I'm going ahead. I continue my walking. I'm touching the 1.2 ohm resistor. So at the 1.2 ohm resistor, the current is coming with me only. So take it as plus 1.2 I. Then after that, you keep on walking continuously. So touching the positive terminal of the 5 volts battery. For touching the positive terminal of the 5 volts battery, so directly you can take it as plus 5 volts. And then you continue the walking. You stop here. And 0.6 ohms resistor current is with you only. So 0.6 I. So you don't stop walking now. So you continue, go ahead and you reach the original point. That means you have completed the loop. So now in this context, the entire thing what I have made, you have to make exactly equal to 0. So this was what KVL says us. Okay, so now we'll try to go ahead 2.2, 1.2, 0.6, and I'll try to show this with a different color. Minus 26 plus 9 plus 5. So I'll try to write together. Minus 26 plus 9 plus 5 plus 2.2i plus 1.2i plus 0.6i is equal to 0. Okay, so this is minus 26 plus 14 plus, so this is how much? So 4 volts, sorry, 4 value, and it is exactly equal to 0, 4i. So 2.2, 1.2, 0.6, 4i. So now 4i is exactly equal to 26 minus 14. So 26 minus 14 is simply 6 minus 4, 2, 2 minus 1. So I is equal to 12 by 4, which is equal to 3 amperes. So this is how you need to calculate the value of the current flowing throughout this loop using a simple KVL method. Okay, so I have calculated the value of I. Now the unknown parameter is only V1. Okay, how will you calculate the value of V1? V1 is the voltage drop across 2.2 ohm resistor, something like this. So this is a 2.2 ohm resistor, and the voltage drop across this is V1, and you need to calculate the value of I. Okay, so how will you calculate the value of I? It is very simple. The current is entering the positive terminal now, so that is V1 equal to, the drop is plus 2.2 into I. So this is very, very important. So V1 is equal to 2.2 multiplied with 3 amperes. So the voltage drop across this is simply given as 6.6 volts. So the important observation what you need to make is, whenever you are walking, if the current in the element is exactly with you, then take it as positive convention. If the current is coming opposite to you, take it as negative convention. So try to solve all the problems using the same approach. Grantedly, you will be getting the excellent results or accurate results to get in the solution analysis. Okay, not only this, applying KVL in a simple loop. Next class I'll try to consider some complex problems where you have one loop, two loop, three loop, four loops, something like that. There also you'll try to apply KVL in individual loops. That is what we call it as a mesh analysis. There also I'll try to follow the same approach to calculate or to apply the KVL in a simple loop. Okay, so with this I am closing this session. So in the next classes we'll try to go ahead in solving some more problems on KVL, and we'll try to have a deep insights about the concepts of KVL. Then slowly we'll try to enter into the concepts of KCL, Kirchoff's current law. Okay, so thank you for giving this opportunity. So this is Dr. Vijaya Babu signing off.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.